Hello, Neil Shearing here from Epicentering. I've got a bit of a video presentation for you today, and it's a bit scientific. I've called it, Is Depression a Mind Virus? And as we go through the presentation, hopefully you'll see why I've called it that. As I say, it's a bit scientific. I kind of fell down a rabbit hole yesterday, and I'm going to take you down that rabbit hole. It's all a bit hand-wavy in science. It's all a bit speculative. But I think it's really interesting as to the potential cause of depression. So I haven't nailed down all my scientific concrete references like I would normally like to, but given that it's a bit of hand-waving, a bit of fun, we'll maybe unravel a bit of science related to depression. And please forgive that it's not 100% nailed down pure science. Okay, let's get stuck in. So I was watching this TED Talk yesterday by Turhan Canley, who's a professor of integrative neuroscience at Stony Brook University. And he was saying, is depression an infectious disease? So is it caused by something like a bacteria, something like a virus, something like a parasite? And he gave a very interesting talk, and I wanted to kind of dig further into it. So I was looking at what actually causes depression. Do we know? If you walked up to a doctor or a scientist and said, do we know what causes depression? They would say, well, we don't really know. Beyond life stressors, which can be acute, such as a divorce or bereavement, or can be long-term stressors, such as your boss who's always on your case, or stress such as, I don't know, caring for an elderly relative, something like that. So beyond life stresses, which can be acute or chronic, a genetic background that may make you susceptible to depression, and poor mood regulation skills, we don't really know what causes depression. But regarding whether or not depression is caused by your genes, it is, but not to a huge degree. So on this graph, I've shown the hereditability is on the left axis. Now I've taken this from Genetic Contributions to Bipolar Disorder, Current Status and Future Directions in Psychological Medicine 51, issue 13, pages 1 through 12. So it's free to use with attribution. So that's the attribution. So if you look at all the disorders that they've looked at two different types of studies that try to show the hereditability of these different disorders. So they've looked at twin studies, which is the fuller bars, and they've looked at single nucleotide polymorphism studies, which is the smaller internal bars. And they've tried to compare the two. But overall, you can see that with this giant pink arrow that I've added, major depression is not exactly one of the most heritable disorders when you compare it to bipolar disorder, which twin studies say is over 80% heritable. Autistic spectrum disorders, roughly the same. Schizophrenia, attention deficit hyperactivity disorder, anorexia nervosa, I think that's alcohol dependency. And so you can see you've got OCD there, and I think that's Tourette's syndrome in between the two, between major depression and anxiety. But you can see it's not particularly heritable. So there aren't genes that are directing depression and anxiety to the same degree that they are bipolar disorder or autistic spectrum disorder. So that means that the environment must play a greater role. And considering the hereditability there is about 40%, just eyeballing it, which is a bit of the scientific hand-waving going on, then you can see that the environment plays a much bigger role in depression and anxiety than it does in the diseases that are more heritable. So we can kind of say that genetics is not so much of an issue. We're not going to pin down specific genes that are the cause of depression or anxiety. The environment plays a much bigger role. Okay, so we're left with stress and poor emotional regulation, which to my mind are pretty much two sides of the same coin, because stress is effectively a situation perceived by the person to exceed their emotional regulation capacity. So if you've got a certain amount of emotional regulation capacity and a stress comes along that's, within that amount of control that you have, it's not an important stressor. It doesn't get you stressed out. Whereas if a stress comes along that exceeds that capacity, or multiple small stresses combined exceed that emotional regulation capacity, then you're stressed out. So they're kind of two sides of the same coin. So psychological stress causes ongoing activation of the stress response, the fight or flight response, and downstream inflammation. So having these either a big acute stressor or multiple ongoing small chronic stressors will generate inflammation in your body. And inflammation seems to be very important to the story of how people end up with depression. In addition, infections also cause inflammation. Obviously, the body is being attacked by something, be it bacterial, be it viral. And if stress is the root of depression, infections should contribute to depression, right? So if your psychological stresses, say bereavement or divorce, are causing stress and inflammation, and that causes depression, then from the other side, if you have an infection with a virus that causes inflammation, then shouldn't that trigger depression, or at least contribute to it? So viral infections are often cause. Oh, that's good English. Viral infections often cause similar changes to those seen in depression. Irritability, sleep changes, eating more or less, exhaustion, reduced sociability, anhedonia, so the inability to take pleasure from anything. And personally, I remember when I got COVID, I became irritable. I just wanted to go away and sleep. I didn't want to deal with people. I didn't want to deal with things. I didn't want to deal with anything. I wasn't taking any pleasure from anything. When I had COVID, it was like a 1% reminder of what depression was at its extreme. And it was a very, very interesting feeling to be exposed to I was like, what is this? Is this the start of depression? It's like, no, you've got, a viral illness. You've got COVID. Oh, right, okay. Well, they're a bit similar, although depression is massively amplified. But it was very interesting. So viral infections often cause similar changes to those seen in depression. And a viral infection is a stress on the body, so perhaps life stressors and viral stressors have a common pathway, inflammation, which is, as I was trying to point out. So this is interesting though. Treatment for viral infections such as hepatitis can include interferon. And when you give people interferon, it's like an amplification of the immune response, because I think, I'm not a medical doctor, but I think it's hard to treat hepatitis. I think it's B and C. I'm not so sure whether A is different or not. But they kind of evade the immune system. I think it hides in hepatocytes. And so one way to help the body to get rid of the hepatitis infection is to amplify the immune response by giving people interferon. And the interesting thing about that is that after treatment with interferon, many patients develop depression. So there's the link with the immune system again. And here I'm quoting from a study from antiviral therapy. It says patients with a history of major depressive disorder were excluded. All right, so we're not including people who already had depression. So we're starting with a clean slate, as clean as could possibly be. And in this study, they looked at people who were affected with hepatitis C and co-infected with HIV. And it says of the 113 co-infected patients who started interferon alpha therapy during the recruitment period, 45, so 40%, developed symptoms of depression, sadness, tiredness, and apathy. But what is also said in the introduction to that paper is that several authors have observed that infection with hepatitis itself, even before interferon therapy, has been associated with symptoms of depression in approximately 24% of cases. So the actual inflammation generated by the hepatitis infection may have contributed to, there's the hand waving, may have contributed to 24% of those people displaying symptoms of depression. And then when they were treated with interferon, which amped up the immune response and generated more inflammation, it went up to 40% developed symptoms of depression. Now, that's not a direct result of the experiment. The direct result of the experiment is that of 113 people, 40% developed symptoms of depression. And they're noting in the introduction that approximately 24% of people developed or had depression or symptoms of depression before even getting interferon treatment. So one is a result of this study, and one is interesting to note that has been seen elsewhere. But even so, if we extrapolate from that, the infection itself may be generating symptoms of depression, and then the treatment with interferon looks like it causes even more, a greater percentage of people to display depression. So you're starting with presumably healthy people who haven't got any infection, would have low levels of depression. Then you've got people who are infected with the virus that have higher levels or symptoms of depression. And then you've got people who are, in this case, infected with hepatitis C and HIV. And then were treated with interferon, and 40% of them develop symptoms of depression. So again, it seems like inflammation is playing a critical role in the development of depression. Okay, so I'm looking at a different paper here. I'm quoting a different paper, and it says, in recent years, many researchers have shifted the prospective cause of depression to viruses. A meta-analysis found that depression is associated with Borna disease virus, HSV1, that's herpes simplex virus, varicella zoster, and Epstein-Barr virus. Related studies have shown that viruses produce depression specifically by affecting glial cells. Viruses can infect glial cells in different ways, and glial cells can produce immune responses that damage the brain and lead to depression. So glial cells are thought to be like, hand waving, are thought to be like helper cells next to neurons, around neurons, and help neurons do their function. That's my basic understanding anyway, not being a specific neuroscientist. So the infection of glial cells is causing inflammation and immune responses that damage the brain and lead to depression. So that's multiple different viruses being associated with inflammation in the brain and depression. So what if you have a healthy person and they become depressed? You don't know that they've got hepatitis, or that they've got HIV, or that they've got any kind of viral infection. Could someone become depressed without a viral infection? It's an interesting question. Let's look at that for a few moments. So, we mentioned on the previous slide, but one, HSV, herpes simplex virus. And if you think that HSV, the cold sore virus, stays in the nerve cells for your lifetime once you're infected, but in a latent state and undetectable, so it's not producing new viral particles. You couldn't tell you've got it, but it stays in a latent state. And I love how it says as an episome in the nucleus of neurons. So it gets into the nerve cells, it goes into the nucleus, and then it stays there as an episome, just latently sitting there. Actually, it's doing stuff. It's actually producing, I think I read, a protein from, or an mRNA from one gene of its genome, which silences all the rest. So it's only when you're stressed or immune stressed by, say, another infection or something, that an outbreak occurs and you get a cold sore. So the HSV virus is able to stay latent in the body at undetectable levels, and then, when you're stressed, can have an outbreak and produce cold sores. Now, this is where we get very speculative. Consider that 8% of the human genome, so your genes, your DNA, 8% of your entire DNA consists of embedded viruses that got into your DNA once upon a time in evolutionary history and have stayed there and have been passed down through generations. These are so-called endogenous, meaning inside you, retroviruses. So they've come from the outside and they've gone back into your DNA. They've inserted themselves into your DNA. So what if immunostress, so chronic stress or acute stress, which led to activation of the immune system, leads to inflammation, then activates these viruses, leading to inflammation within the brain itself. So within the brain, each cell has copies of your entire genome. With these endogenous retroviral sequences within your DNA, and what if, when you're stressed, beyond the limits of your emotional regulation capacity, these viruses, or a certain subset of them, are activated in the same way that HSV, herpes simplex virus, is hanging around in the nucleus of the nerve cells and gets activated by stress and causes an outbreak. The only difference is that HSV hangs around as an episome within the nucleus, whereas these endogenous retroviruses are actually in your DNA already. Would we then see the hallmarks of viral infection/depression, but with no outward signs, such as runny nose, sneezing, or a cold sore? So, when you get a cold, you run around sneezing, coughing, runny nose, and throw yourself in the bed, and everyone's like, "Oh, poor thing, you're ill, you'll be okay, just rest for a few days." Or people can see a cold sore, and they're like, "Oh my goodness, that looks painful, you must really be stressed to the eyeballs." But with depression, you don't have those outward signs. It's very strange that you could be effectively fighting massive inflammation within your brain, potentially, if this hypothesis is true. But either way, whatever's going on inside biologically, there's no obvious sign externally that you're fighting a viral infection or that you're struggling to cope with life itself. There's no broken leg, there's no runny nose, there's no physical sign. So people really don't understand how serious it is. What if the stressors activating the immune system were long-term? Would the depression then get worse as the infection wasn't dealt with? So because people don't know, if this hypothesis is true, that you're fighting a endogenous virus, then people are left to struggle with it. And if the immune system can't get on top of it because the chronic ongoing stress doesn't stop, presumably the viral activity continues and you're just always fighting this virus, this depression. And people don't see any outward signs, like apart from you withdrawing, becoming antisocial, not taking pleasure in anything, having a black cloud over you the whole time, and really struggling with life, but that's generally like becoming frustrated, maybe irritable, something like that. But there's no physical signs of an illness or a virus that people expect to see. And therefore, People don't go to the doctor as often as they would with something that was treatable. Therefore, it gets worse and worse and worse and worse and worse. So this is an hypothesis. In science we call it hand-waving because it's all guesswork, but it can take us into interesting ideas, thought experiments, avenues for research. But we don't need to know the exact mechanism of what causes depression, even though it's very interesting to speculate. We don't need to know scientifically worked out step by step every nuance, subtlety and detail of the exact mechanism to say, well, if it's true, what could we do about it? Right now, let science catch up in its own good time. If this is true, what could we do about it? And all the suggestions in epicentering help to reduce distress and build up emotional resilience. So you can come at the problem in two ways. If you're suffering with too much distress, and people use stress to mean distress. There's also eustress, which is something different, and I'll go through that further in a different video. But say you have too much distress, you can either find ways to bring down that level of stress, or you can find ways to cope better with that stress, such that it falls within your level of emotional capability to deal with it. And building up the emotional resilience. I don't believe it's a coincidence that implementing epicentering pulled me out of a devastatingly deep depression. And the ways that epicentering works is to do things, change lifestyle factors to reduce stress and build up your tolerance to stress, and emotionally build up your emotional resistance to stress. That's what epicentering does. So if this hypothesis about endogenous retroviruses is true, it's a fascinating story, and I'd love to see it mapped out and the details filled in. But it doesn't have to be completely finished as a scientific story before we can jump in and say, look, the way epicentering works is congruent with this model of how depression starts and forms. It's about inflammation, and there's huge amounts of studies that show that obviously viral infections can generate symptoms similar to depression, and that seems to happen through the mechanism of inflammation. So we need to reduce inflammation, and the way we do that is by reducing stress. And the way we do that is by changing one of many different lifestyle factors to reduce the stress on us, which brings down inflammation. At the same time, we increase our emotional resilience to stress. So we're tackling it in a twin way, two ways, by reducing stress and increasing resilience. And that's the way that epicentering works. And that's how I believe I put my depression into long-term remission. Okay, so I'm putting things together at the moment. I hope you find it interesting. If you'd like to find out more, you can follow me on almost all the social sites or visit epicentering.com. Thanks for watching.